The bowling ball has undergone a lot of changes over several centuries to become such a striking success. From a crude stone to carved wood to rubber to molded polyester, it's been reinvented numerous times. But the latest version has turned out to be a real winner. Technological advances have reshaped the bowling ball at its very core. No longer round, the nucleus is asymmetrical, which causes the ball to curve towards the pins as it rolls down the lane. They make the cores from polyester resin, blending in minerals like barytes, silica powder, and limestone. The result looks like chocolate milk, or make that hot chocolate, because a catalyst triggers a chemical reaction that heats it up. As they pipe it into the molds, it quickly starts to cure and solidify. In just 2 minutes, it's ready to extract. This core is oblong, flat on one side with a knob. There are different versions of this core design, each one carefully calculated to manipulate the bowling ball's performance at a specific skill level. They now drill towards the center of the core to make a pinhole. This allows the core to be suspended in just the right position in a second mold. This asymmetrical core is about to be encased in a more uniform sphere. They tamp the core into the bottom part of the mold and then lock down the top half. After all, they don't want any leaks as they pump it full of plastic. It's a liquid polymer blend. A special chemical in it causes the mix to solidify slowly. It can take days for it to harden around the core, depending on the formulation and type of bowling ball being made. When they knock it out of the mold, all is revealed. That asymmetrical core is now sealed in a very symmetrical polymer shell. Next, it's into a third mold. This one will seal the bowling ball in an outer skin called the veneer. This veneer has been scientifically formulated to enhance the ball's traction as it hooks towards the bowling pins. It's made of colorant, plasticizer, a chemical called ISO, and urethane. Blending these ingredients produces high-performance polyurethane. As the mix flows into the molds, a chemical reaction causes it to heat up and solidify in just seconds. Then it's into an oven to boost the chemical reaction. Next, a spinning grinder shaves off the bump which was formed by overflow at the mold's intake tube. The removal of this bump rounds off the shape of the bowling ball. With its 3 layers, this bowling ball looks a bit like a big bonbon when it's sliced in 2. And while it may look sweet, it needs a bit more work before it's ready to take on the competition. A lift system delivers the bowling ball to a sanding operation, which roughs up the surface. The coarseness of the sanding varies, depending on the performance goals of the particular ball. This machine heat stamps trademark information onto the ball. They do one last sanding as a constant flow of water removes the powdery residue. The more polished the surface, the less pronounced the ball's hooking action will be. Even this last sanding is geared to a certain performance standard. Once they buff the surface, all that's left is to custom drill the finger holes. With this bowling ball in hand, success should be within striking distance.